Hello everyone, welcome to Vishwablooms. So in this video we'll be looking at Optics Concept 5 MCQs Class 8 Physics Techno. So let's begin with the video. First, in the previous video we have already covered the detailed explanation of Concept 5 with all the ray diagrams, where the object is positioned and where the image is going to form. So everything is detailedly available in the previous video. You can check out in the Physics Techno playlist for Class 8. Okay, so today let's begin with today's session about the MCQ part for that particular concept. So firstly, we will discuss the clarity achiever number 5. So yeah, first question says a convex mirror is used to form a real image. Okay, is to form a image of a real object. So object is real. Okay, so what is the image going to form? Okay, so the image is obviously, remember one thing, it will lie between pole and focus. It is diminished in size and it is erect. Now how do I get to know all this? You will think, right? See, convex mirror has only two cases. First and foremost thing, see, convex mirror is something of this sort, and only there are two things. See here, pole, and here it is focus. Okay, object is going from here itself. Okay, wherever you keep, here or here, and if you keep at infinity, it is going to come exactly on the focus only. So these cases we have detailedly studied, so that's why I'm not explaining in detail. So these three are correct actually. Okay, it is going to be erect, but it is not going to be real because it is behind the mirror, right? So fourth option is going to be wrong. Erect image is always a real image, is an virtual one, but erect is a real one. Okay, so here a real image is going to be formed. So option is D. Okay, yeah, first one. Now let's look at the second one. The mirror to be used to obtain a parallel beam of light from a small lamp is, so there is a small lamp and you need large parallel beams of light from this small lamp. So what is the mirror you are going to use? Is it is going to be a concave mirror always. So concave mirror actually gives large parallel beams of light. That is why it is also placed in car headlights. You know headlights, right? The front part of the car will have some lights. So there also it is used in order to get large parallel beams of light. Okay, from small LED also it can give you large amounts of light. So for concave mirror is the answer and C is the option. Okay, so third one, to trace the image of an object due to spherical mirror, the minimum number of rays required. So this is also discussed. So for tracing out the ray diagram or the image formation where image is going to form, ray diagram needs at least 2 rays. Okay, it needs at least 2 rays in order to find out the image position. So it is B option. Next we will see the fourth question. The position of the image of an object due to spherical mirror depends on. So position of image of an object due to spherical mirror. What does it depend on? Obviously object distance. Okay, what is it? Object distance. See, wherever you place object distance, object there only, obviously that is only the main factor which is going to tell us where the image is going to be formed. So object distance will be the right answer for this, and it's option A. Clear? Now fifth one, if we see, a ray parallel to principal axis incident on a concave mirror after reflection passes through. So first we should take one concave mirror. So concave mirror, cave part is reflecting part, you know, right? Okay, so a ray is parallel to principal axis. So let me draw one ray parallel to principal axis. So this is the focus, this is the center of curvature, this is the pole, and this is the principal axis. This line is principal axis. So one line is drawn parallel to this. Okay, done. Okay, after reflection, where it will pass? Obviously this is a rule that it should pass from focus. So the ray rules also we have studied, right? So that is what. So focus is the answer for this, and option is B. So you can check out the explanatory video there also I have told. Next, sixth question. A ray passing through the focus of concave mirror after reflection is parallel to. See, now same thing actually. This is the concave mirror again. We have See, this is the focus, this is the center of curvature, this is pole, and this is the principal axis. So P axis I am writing. Okay. Now what he told is a ray passing through focus of the concave mirror. Suppose it's passing through the concave focus, then obviously it is going to be parallel to what he is asking. It is going to be parallel to principal axis. So principal axis, it is going to be parallel, and it's option D. Fine. Next we have seventh question, which is a statement type of question. So first we will see statement A, then statement B. Okay. Statement A, a ray passing through the center of curvature after reflection retraces its path. See, in the rules also we have ray rules that if something is passing through center of curvature, if it is going in this way, obviously it is going to return in the same way. Okay, so retraces its path, that's what is explained there. So obviously statement A is a true statement. Okay, now we will see statement B. Center of curvature and pole of the spherical mirror lie on principal axis. Yeah, see here, center of curvature and pole, this is pole, all lie on the principal axis. So no need to draw separate figure for this. So by that only I am able to tell that statement B is also true, and both are true. So option A would be correct for this. So now we will see the 8th question. Among the following statements, the incorrect one for real objects. So incorrect, you have to see this word, incorrect for real objects. Okay, so let's see one by one. Option A, what does it tell? Magnification produced by convex mirror is always less than 1. Yes, it's obviously going to be less than 1, because see, why it is always less than 1 is, see, convex mirrors produce very small image actually. Okay, concave gives very big image, concave mirrors, whereas convex, if I am talking, they'll give a very small image. So that's why it is correct. Okay, B. A virtual erect same size image can be formed by plane mirror. If you take a plane mirror, what you will get? You will get an erect image, you will get a virtual image, it's not something real, and obviously whatever size is yours is going to be the same. So that is correct, and obviously B statement is correct. Now see, if you take a virtual erect magnified image can be obtained by concave mirror. Just now we discussed, right? Concave mirror will give a virtual image and it will give a magnified. If it is a virtual, no? Virtual image also it can, erect also it can, and it will give the magnified image. Obviously correct. Next, if you see D1, a real inverted same size image can be formed using convex mirror. No chance. In convex mirror, obviously just now I discussed, right, magnification is less than 1 because it will produce small images. This is the wrong statement, that's why D is correct. In the sense, this option is correct for this. Now, 9th question, a mirror produces magnified erect image of an object. The nature of the mirror. What it produces? An erect image and a magnified image. So erect, so virtual and erect, no, obviously erect images will be virtual. So which will produce this? Obviously magnified, when you see, you can actually simply say concave, but erect and virtual also, last case it will produce. Okay, so that's what the option. Next we have the 10th question. Among the following, the one that which is not the case with image formed by concave mirror, not the case with concave mirror. Okay, so let's see, it may be erect or inverted. Okay, yeah, erect and or inverted we have seen, so A is correct. Now B we will see, it may be magnified or diminished. Yeah, that condition also we have seen. Okay, it may be real or virtual. Yeah, okay. D, the real image may be between pole and focus. No, we have not seen this. So D is incorrect, and that is only the option for this question. Okay, now let's move on to the silver package. Yeah, so first one, we have a passage itself, and under that we have 5 questions. Okay, so you can just simply read the passage. So that passage explains about the position of image, how you can locate it, that's all. Okay, so there is nothing much important, but you can read it and take 2 minutes and read it. So but I will be moving on to the question. If you want to read it, you just pause it. Okay, first one, what is the position of the image formed? So here there is a concave mirror, and he gave you pole, he marked the pole, he marked the focus, he marked the center of curvature. So from infinity there are rays coming up here, and yeah, here also below, and here you can observe that on the principal axis also he has given two arrow marks. See, focus is here, he gave one arrow mark towards this direction, another one towards this direction. Now what is the position of the image formed? Obviously it is the focus, okay, because it is showing very clearly, so it is focus, option B. Okay, next, for under first one only we have second bit. What are the characteristics of image formed here? Okay, so they have given one condition. Here we have pole, here we have focus, here we have center of curvature. So image is placed object is placed exactly at C. There is a ray passing parallel to principal axis that will intersect at the focus in this manner, and again there is one more ray coming up from the focus, so which is going to be parallel to principal axis in this way. Okay, now see where they are meeting here, right? So I'm going to draw same arrow mark here. You can observe that the object and the image both are formed at one position only, that is, they both are formed at center of curvature at C. Fine. Now what are the characteristics you can observe? So the image is obviously inverted. First and foremost thing, you can say it is ulta, and it is the same size of the object. Yes, same size, and you can observe that it is towards the mirror itself, it is not behind the mirror, so it is a real image also. So same size, inverted and real. Okay, now so let's look at the options first. Okay, A option says that image is real, so whatever I have written is here, so this is A. And B option says that this is inverted, that also I have written. Now C option says it's diminished. No, not at all. See, it is the same size of the object. Okay, image is same size of the object. So C cannot be the answer, and options are A and B. I don't know, it's actually single answer type or double answer type, but all the above cannot be the right answer because image is not diminished. Here it is the same size of the object. So just consider A and B. It's damn sure that C is not the right answer, so you cannot take D as the answer. All the above cannot be the answer. Fine. Okay. Now first main, again third subdivision, let's see. To get the image at infinity is to be placed at, okay, if you want to get the image at infinity, the condition also he has drawn and showed you towards the right. He has given the pole, he has given the focus, he has given the center of curvature, and object is placed at focus. A parallel is drawn to principal axis, it will come towards from the focus again, and again there is one more ray passing from the pole which will give the same angle at the pole. Now here these two lines never meet, and obviously image is going to be formed at infinity and it's going to be highly enlarged. So where to get the image at infinity, where should the object be placed? It is at the focus. He has given the diagram only very clearly. Okay, so focus, option is D. Next, first bit, again fourth part of the question. The image formed by concave mirror is, okay, now it's actually generally real only it is formed, but in only one case there is a virtual image formed. So you cannot say always real, no, you cannot say always virtual, and is certainly virtual if the object is real. No, is certainly real if the object is virtual. If the object is virtual, then the image is real. Okay, so D is the right answer. And we come to the last part of the question. The mirror used in solar energy reflectors. So solar energy reflectors, what is the mirror used? So you all know, just think of it commonly. Okay, now this is sun, you will get solar energy from sun, you will have that reflector here. Okay, solar energy. Now what do you think is going to be that mirror? See, obviously we want more and more energy, so what we will use? Concave, because it gives large parallel beam, right? it produces more energy. So the image used will be concave mirror. Okay, so option is B. And with this we come to the end of this concept. So do like, share and subscribe to Vishwablooms. Don't forget to click the bell icon. Thanks for watching our video. Bye bye. See you in the very next video.